Okay, hello everyone from home. Everyone who was here in the room, please ignore me. We're just giving a little wrap up for everyone who's following us from the live on YouTube. Just want to say sorry for the technical issues. We had some problems here connecting with the webcam and so on. The masterclass is going on. Now I'll give the microphone to Giulio De Sana and Romano Mancini, who are presenting the masterclass, and will give you all the details to see what we have done until now and how to follow up the rest of the masterclass. Thank you for listening. Okay.
Hi everyone, I'm Giulio, and up until this moment we tried at least to define the building blocks of a Flutter application, which we think are the UI, so all the widgets and what you can build the interface with, and the navigation, so moving between the pages. Up until now we just defined some pages, nothing important, some auth processes, and we just used the auto-route package to manage all the navigation. You can find all the code in the linked repository, and all the code is divided by sections. So if you feel lost or if you couldn't complete some code, you can easily check out to the next section just to be aligned with everybody else.
now. We're gonna just rush through the last theoretical concepts and then move on. We're probably gonna skip the PowerPoint part. Let's just do the actual live coding so that we can finish this up a little bit earlier, and yeah, let's go on, I guess.
Okay, so the mic is again working. There we are. So the next section, so just pretend that we understood everything up until this point. So we saw the UI, we saw the navigation, basic concepts, but I understand that there's a lot of code to digest. So again, I highly suggest you to follow the repo, and for anything that you don't understand, try to refer to that, and we are going to collect all the questions in 20 minutes after the next section. So now that we've seen the interface and the navigation, we wanted to talk about the state management. So we saw stateful, stateless widget, but that's not the state we are talking about, since that is the front-end state. Let me put it like that. So again, in the login page, we have the set state, the loading, and with the set state, we can just work on variables defined inside the widget. Again, a little bit limiting. Like, for example, we want to introduce an authentication in our app. And of course, we don't want the authentication to live inside a single widget. We want the authentication to be above everything, because we are going to need it in different parts of the application, of course. So, for example, we saw how we can protect our routes by checking whether the user already logged in or not. But we need to access the user object from the router. And for doing so, we are going to use another package called RiverPod. RiverPod is said in simple ways. I'm sorry, but I got disconnected from the Wi-Fi. Beautiful. As I like to say, is a framework inside the framework. Don't be so scared, because we are going to just scratch the surface of what RiverPod can do. RiverPod, also its name comes from the provider. Sorry for the Italian version of, okay, we can change it. It comes from provider, and provider in the web environment means a class that exposes some logic that can be used or consumed in the UI. In our case, we're going to use RiverPod mainly for the user state, and also for making the logic communicate in a seamless way with token, which should help us understand whether the user is logged in or not, again. So here we check for the token. If it's not null, it means that the user is logged in, and we are going to return the user model. User model, which is defined, again, in the models folder. Very, very simple, very Java-like. Nothing special. So you have, as always, your attributes, your constructor, and in this case, a get attribute, which is more like a computed attribute. So instead of returning a static object, we can actually trigger some code by interrogating the attribute of the model. But enough said for the model. Going back to the out service, you can see that we have the login function, sign up, request password. In conclusion, everything that you need to handle the user. And all of this logic will be used inside the notifier. The notifier is called like this because every time the state inside the notifier changes, the notifier is going to notify, sorry for the word game, is going to notify the UI. So it's going to update it accordingly. The strong thing about RiverPod is the fact that we can reload only portions of a widget. Meaning that if we have, for example, a profile page with only a single section that is going to take attributes from the user, for example, we want to show the email of the user. If the email changes, only that section of the UI, so only where the email is used, is going to be reloaded. This is going to make our application way more fast because not all the widget needs to be extracted once the state changes, thing that is happening with the set state. So every time we call set state, the whole build function is going to be rerun from scratch. But with Riverpod, we can actually only wrap certain portions of the widget to make them dynamic. In this case, you can see that I defined the whole widget as a consumer. The consumer that I said before, it's what is going to consume our logic, defined in the service and accessible through the notifier. Going straight to an example, just to make things a little bit clearer. Here, I'm calling the login function from inside the notifier. So here we have the login that is accepting an email and a password. And once the login is finished, inside the out service, which is going to return the current user, so this model, once it's finished, we are going to set the state with that object. By doing so, as soon as the login or the sign up or the get current user functions are completed, the state will be updated, and of course, the UI is going to be updated accordingly. So coming back to the login page, we use ref, which is an object exposed from Riverpod, which allows us to interrogate the notifiers. So here we go ref.read. Here we access the actual notifier, and once we accessed it, we can call the functions defined inside them. Nothing very special. The only stuff that you must remember to make a Riverpod work is, again, a decorator. In this case, with the keep alive attribute set to true, because being this the user, we don't want the notifier to be disposed once a page is reloaded, for example. So here, thanks to this decorator, once we run the build runner, as we did for the outer route, it's going to generate this file, which tells us nothing, but is going to make this notifier accessible object that we've seen in the login page. And that's basically it for Riverpod. Again, it's a very flexible framework. It's not used only for this use case. It can be used also for just accessing some logic from the front end in the same fashion as we did for the notifier. But again, I found it more useful for this kind of use case rather than other stuff. So I'm going to change the branch, because we have a whole branch dedicated to this argument, which is going to be the section 5 state again. And the last stuff that I want to show you, it's in the home page, where we are going to watch our state. We saw in the login with the watch, sorry, I lost my page. With the watch, we can access the state. And thanks to this event, the page is going to be reloaded every time the user state changes. Once we have the state, we can use it as a classical object, a Java-like object, so access the user.name attribute. Here I wanted to see, oh, the application is white, sorry. Let's rerun it from scratch. Let's see what it's doing. Oh, internal stuff. I'm going to give him one more second. OK, it worked. So here we are already in the home page, because we already did the login in the last section. And as we can see, we have our name displayed. Where does this name come from? We can go here for commodity, sorry. if we go again in the out service, we can see that from get current user, we are going to return the user model here in a static fashion because everything is mocked up until this point. And as you can see, the name is John Doe, which is taken from the home page from the user.name. And again, we can see it right here. So if you have any question about the state management or the Riverpod framework, I know that this may feel complicated, but again, I just tried to highlight the the crucial stuff. And if you have any question, I'm here. I'm going to give you maybe a couple minutes just to watch the code with your own eyes and your own pace. And again, any question, I'm here.
From now on, we have just 2 more sections, and then we're done with the code, actually. So it's going to be like another 20 minutes or so, and then we can wrap it up. Shall we just go with the code? Okay. Sure. We're going to talk now a little bit more in depth about how you can actually make this app communicate with a server, so you can actually like make requests over the internet and stuff. So you can actually make it more, yeah.
That depends on your choice, of course. But in this case, I'm just betting on the thing that the login function is not going to throw any exception. So if everything goes well, it goes directly inside the code to go to the home page. Otherwise, it's going to catch the error and show invalid credentials for this case. Yeah. So after the state, again, we wanted just to show you another package. Again, it's very package-centric, this lecture, because Flutter, out of the box, can do almost everything we've seen so far. But these packages make it way, way more easy to handle all of the heavy stuff. So we're going to show you the Dio package, actually, which is nothing more than a API handler, let me put it like that, a HTTP request handler. So we are defining this time a base service which will work as a basic interface to make all the other service work. And inside here, I defined at least a base URL, in this case the local host, and most importantly the client which is the Dio client. Here there is some boilerplate stuff where we are just defining what the base URL for our application is, the content type, and then here I'm adding an auto interceptor, which I think it's a little bit out of scope for this lecture, which just makes sure that each time we are calling our APIs, the authentication token is attached to the call. This just to make sure that for every time we call an API, we don't have to add the token manually to each function. So just to show you what is going on in the out service, which right now is extending the base service that we just seen, you can see that we can call our APIs like this. So client, which is defined again in the base service, there you have it. .get because we are using a get HTTP method. Otherwise, we can use the post as in the login. So what is going on under the hood? Under the hood, our client is putting together all the stuff that I said, so the base URL, the URL that we are giving him right now, and the authentication that we have defined inside the interceptor, which I'm just going to briefly show it to you just to understand why I'm not explaining a lot of stupid code actually, but it's just handling the fact that when we do a call, the token is attached, making sure that we are always authenticated across all services and across all functions. And that's it. With this little code, we can do an API call already authenticated and already handled with all the possible errors that can come with it, like connection errors. If our user doesn't have an active network connection, Dio is going to handle it for us, blocking the request before it starts. We said up until this point. Okay, again, if you have any question, we are here. Otherwise, we can proceed to the 7th and last section.
We're just going to refine a little bit the logic now and do the last implementation with Firebase, which is actually a very powerful tool. Let's call it like a service, a cloud service, that you can use to store data and to do authentication, to manage the users, and so on and so forth. So this is going to be the last section of this. Yeah, of this lecture. We're going to refine the logic a little bit and then introduce Firebase. Of course, we're going to do it like very quickly because it's a very deep topic. So we're just going to wrap it up, I guess. So you can just, if you're still following, you can go to the last section. So you can do just git checkout and then go to section 8, which is going to be actually the last one. And yeah, that's going to be it. So if you have any questions in the meantime that we switch the branch, you can just do them. Otherwise, we're going to skip to the end of this lecture. Yeah.
Yeah, because from the out notifier.dart, if you run the build runner, as I'm doing actually right now, so with this command, thanks to the decorator up the out notifier class, the build runner is going to generate the out notifier.g.dart. So if you have errors, maybe you have some other missing files. Otherwise, after the build runner is done, you should have no errors in your code. Oh yeah, if it prompts you with a choice, just say delete, because that means that all the generated files are going to be deleted and regenerated from scratch. Yeah, we didn't version the generated files because I don't think this is the case, but in a lot of cases, the generated files can maybe have a reference to your local files. So in order to don't have any problems of importing and versioning the project, we prefer to keep them out of the Git. For this last section, so connecting to Firebase, we preferred including Firebase in this lecture because it has a strong, how can I say, it has a strong relationship with Flutter, being both Google products. So it's very easy also for beginners to include a production-ready backend in their application. So very quickly, because we are also running out of time, to connect Firebase to our application, we have to go, of course, to firebase.com. If you don't have a Google account, I highly suggest you to create one because we are in 2025. Why you don't have a Google account? And with your own Google account, you can go to the console. In the console, you can find, if you have any, your projects, like me. So we have the project that I created for this repository. Otherwise, you can create a new one. But I don't suggest you to go from this route, but we prefer adding Firebase by using their official CLI. So if you write Firebase Flutter on Google, the first link it will show you is add Firebase to your Flutter app. Here the documentation is pretty straightforward. It asks us for a login with Firebase. So you just go to the terminal, and if you don't have the Firebase CLI, you should follow this tutorial. But again, it's pretty easy. It's just an installation, no configuration, no awful stuff. So I'll give you just a minute to download the CLI for Firebase. So, okay, once we have the Firebase CLI installed, we can proceed with a login. I know that not all of you have the CLI installed. Try to follow me as you can while it's installing. But again, pretty straightforward. Firebase login is going to prompt us to, in my case, I'm already logged in, of course. In your case, it's going to open a browser page asking you to authenticate with Google. Oh, no more lights. Yeah. Yeah. So in my case, I'm already logged in. In your case, it's going to open a browser page. Again, I'm rearranging my windows so it's easier. And once that is done, we can proceed to activate the Flutterfire CLI. This is an official instrument given by Google, which allows us to seamlessly integrate Firebase into our project. So we run this command just to install it. And once it's installed, we can run Flutterfire configure. This is going to prompt us by choosing, oh yeah, in my case, it's already configured, sorry. What can I do? Go back to another branch. We're going to skip this. Just to let you know what is going on. With the Flutterfire configure, it's going to show you all of your projects in Firebase, if you have any. And if you don't have any, it's going to force you to create a new project. And once you created it, all from the CLI, it's going to ask you for which platforms you would like to activate the project. In automatic, everything is configured for you because the CLI will see which platforms are activated for your Flutter project, and it will simply replicate that configuration over to Firebase. But what is actually going on with the Flutterfire configure? We are generating two files. The Firebase JSON, which will hold all our IDs, all our keys to connect to Firebase, and also the Firebase options.dart, which is nothing. So as you can see, in our case, we just have the Android and iOS platforms, while all the others will throw an error if we try to run the application with them. Here, as I said, we have the API key. Please don't copy it, otherwise I'm going to get an awful bill at the end of this month. And everything it needs to do to connect to Firebase. But let's see how we can actually use it. So first of all, we need to import the Firebase core, which will hold all the code to actually connect to the Firebase APIs and to authenticate our application. But the main thing to do, we need to do from the code is add this little code snippet to our main.dart. As you can see here, it's already been done. And what this does, it's going to, as you said, initialize all the code needed for Firebase to work. We also added this line that also the Flutter creators don't actually know what this does, but in a nutshell, it make sure that all the code needed for the connectivity and other stuff, so for example, in this case, for Firebase to connect, it's ready. So this makes sure that Flutter is actually communicating with the device it's being deployed on. So after this little snippet comes the important stuff. So here it says to add the plugin we want to use. Down here we can see that Firebase exposes a lot of plugins. Mainly we are going to use the authentication and the Firestore, which is a database. Without wasting any more time, we are going back to the out section where we can see that a lot of stuff has been changed, because all the functions have been replaced with the corresponding Firebase implementation. The Firebase authentication, which we are seeing right now, is pretty straightforward. You can log in, you can sign up, you can request the email for changing the password, you can get the current user, and it's basically doing all we did up until now, but wrapped in a beautiful SDK. So, since it's not that complex, I hope so, here we are defining the instance, which it's not important, it's just the object that is going to expose all of the code we are going to need. And already in get current user, we can see that now we are getting the user, the actual user, from the Firebase authentication. So this allows us to access some user attributes, in this case the UID, which is the unique identifier, you know it, the email, and the display name. All of these that are defined once we are signing up with our user or logging in. Because, as I said, inside the instance, it leaves all the code. So once we log in, as we did before for the network section and for the state management, to understand whether the user was logged in or not, we add a token, a locally saved token. Firebase is doing pretty much the same thing. So when we log in, Firebase is user. So yeah, this little attribute exposes our saved user, and also making sure that it's a Firebase user and not something we defined on the fly. So quickly looking at the methods exposed, as you can see, pretty straightforward. Sign in with email and password, nothing more simple. The only difficult thing is the exceptions that Firebase defines, because there are a lot of Firebase exceptions, as you can see here, but also in other cases. They are pretty complex, but most of the time they are very useful, because they're helping us making sure that the users understand what is going on. So if the code returned from the exception is user not found, we can tell the user, look, there's no email attached to, this email is not attached to any account. Or, for example, wrong password. You can understand that this way of working is not that secure, because someone can brute force its way in by trying different emails up until it finds an email working. But this is a design choice. I'll let you decide what's the best way to do it. And same thing for the sign up. Create a user with email and password. This time we are just updating the display name, so the username, call it however you want, with the name passed from the registration phase. Again, we are always returning a user model, because this service is always speaking to the notifier. The notifier where there was a slight change in the initialization. Here we are again using Firebase auth to listen for any change in the user state. So whenever the user logs in, logs out, signs up, changes anything, this code section is going to be triggered, updating our state in order for the interface to be always aligned with whatever the user is doing with its information. And the rest of the notifier, as you can see, remained pretty much the same. So why is the notifier useful? Also because it can make our code base transparent to the actual logic implementation. So as before we had in the out service, all the functions defined through our APIs. Now we just change the content of the functions, but the functions remain the same. So the notifiers doesn't need to be changed. And this was pretty much the authentication. So the rest of the workflow is the same. When we are logging in the application, the root guard is checking for the user. This time is taking it from Firebase. And in the home page, we always have in the profile page now, because I made the application a little more complex, we always have our user watched through the notifier. So again, the authentication, I think it's the simplest part, only because it's very well documented from their official documentation that you can find down here in the actual authentication tab. And here you can see all of the functions we just used. So the out state changes, how you can access the user credential from the instance we defined, and also how you can authenticate your user, so the functions we already see. But what can we do with the authentication? With the authentication, we can make sure that all the services that we use from Firebase are actually connected to our user. But how can we do it? In this app, we are defining, we are saving some countries gotten from a public available API that you can find in the countries service. There's not much to say about this section because, again, it's out of the scope. You just have to know that from here we are fetching a list of countries. Countries defined mainly from the name and the population and the capital, which are the attributes that we are interested in this time, and also the flag, sorry. But the important thing is the Cloud Firestore. Cloud Firestore, which again has its own documentation right here, which in the Firebase console we can see that it's a NoSQL database. Firebase doesn't have a production-ready SQL solution because nobody is using SQL no more in production environments. Don't ask me why, I don't know, because I find it very, very useful. But what it means to have a NoSQL database, for those of you who haven't seen MongoDB, it's basically a collection of JSONs, nothing special. So you have your documents, which again are JSONs, and inside the documents we have some attributes defined as a JSON. But how can we interact with this database? We install the Cloud Firestore package, again with Flutter Fabad Cloud Firestore in this case. I'm not going to do it because I already have it. And once we've done that, we just define the instance as the authorization. We get the, in this case, DB variable. You can call it whatever you want. And from this, we can access to our collections. So in this case, we just have one collection. And inside the user's collection, we are going to use the UID of the user to create its own document. This is a common way to save, sorry, I got too close to the mic. This is a common way to save user data in Firebase since the authentication section doesn't have a very good way to save personal information apart from the email and the username. So we are going to need to define a collection of users. Each user will have its own document, and in each document we can save stuff. In this case, we are saving the countries that the user wants to keep track of. I can see that the application didn't update properly, so I'm going to run it from scratch again, just to show you where we are going to with the whole app. And again, with the set method applied to a document, we can save some info. While with the get, we can get the whole document. Nothing too crazy. Again, I understand that this can be intimidating because there's a lot of method stuff going on. But once you understand that you can basically work with two things, which are the collections and the documents, you are pretty much there. So you access a collection, you access the document in the collection, and if there's no document with that name, the document is going to be created. Once you do that, the two operations you can normally do on any document, you get it or you send it. Stop. Again, you can do very, very complex stuff. I remember in an application that this query became like 50 lines long because I wanted to fetch only the most close stores to my location given a single time. So the queries can become very mathematical, very complex, and very heavy to carry out. So, for example, you can define some indexes in order to optimize the speed. You can do basically whatever you want. But again, we are just scratching the surface. We are just showing you how you can get something up and running without not too much complexity and not too much boilerplate code, as you can see. And for Firebase, I think that's it. So we saw how to authenticate, we saw how to save data, and just briefly showing to you what other stuff can Firebase do. Like we have some functions, so some pieces of code that can run in an isolated environment in the cloud. We have some hosting options. We also have a lot of generative AI at our disposals. Let me just find, oh, well, there was the AI section. There's this AI logic component which is very useful if you want to create, for example, a chatbot or stuff like that, because this is going to give you access to Gemini. And in a lot of cases, it's going to be free. Also, Firebase, as it comes, it's completely free as long as we stay in the Spark program. If you want to have the heavy stuff, the production stuff, you need to, of course, do the upgrade. But with the Spark, you are sure that you are not using any of your money, which with the side projects, it's very useful. And again, I think for Firebase, that's it.
So the lecture is finally now over, and yeah, that's it. So you can have the whole code on in the repository that I showed on the first slide, and you can also there should be the slides that I actually uploaded now. Yeah, this is actually the finite hub, the ended app, like the complete app.
Yeah, if you go in the last branch and run the app, you're going to see this with the profile, your name and email taken from Firebase, and the actual countries you saved in the Firebase database.
Okay, so that was it. Thank you very much for your attention, especially because it's very late now. So yeah, we hope to see you again for future events. You want to say something, or? Okay, it's okay. Well, you're free to go. Thank you.
Thank you very much.